Greetings and good morning, good afternoon, or good evening for wherever you are in the world right now. Our current video picks up from the first video I made, the first video being a discussion on space and points. The second video picks up from that point, and we now go on to discuss edges. As we mentioned in the previous video, from space we can define a location, and therefore a point. From connected points we can define an edge, which in turn are used to define faces. Video 2 focuses on these edges. So, in the very beginning, there was space, of course, and then there was a single point. Here we have a point right here. What we will discuss is the relationship between edges and points. Now, let's take a point and extrude it out. In the polygon world, what we get is an edge between two points that have been pulled out. Regardless of the direction of pulling this point out, we can always connect two vertices or points. We can always connect two points together to form an edge. If two points are needed to create an edge, we can then take these 2 points, extrude them out again to create 4 edges, which then create a face. It is this very basic building block that creates whole meshes. Let's have a look. If this is a face and these are our edges, this is two triangles. Now, if we decide to create a more dense mesh of triangles, we find that we can create many fantastic objects. And then once we have these edges, we can fill in the space between the edges with faces. Now, just because I did put so much work into these real-time shaders, I will show you again from afar. Keep in mind that this is our starting face, and let us just imagine that we have taken this face and extruded it and cut it and extruded and cut it and extruded and extruded and cut until what we have is a far more complex shape. In this case, the shape we have is that of a face. More than anything else, I hope this illustrates that from two edges and two edges again and multiple edges connected through a myriad of fantastic and interesting ways, dense meshes can be generated. And then you can hide the mesh, you can hide the edges to see the mesh beneath. This is what we're going for. This is our end result, to create a dynamic, intriguing, fun mesh. This is what we're all in the business for. And if it's not for a mesh, it's for an image. We're always going for that final image in this industry. So, let's talk about edges. And we'll just fade this all out. And we'll actually go back to discussing a point of vocabulary. From here on out, a point will be interchangeably used, at least while we're discussing polygons, will be interchangeably used with a vertex. Now, I made that slip up earlier in this video. You may or may not have caught it. I will from here on out refer to all points that create polygons. I will refer to them as vertices, the singular being vertex. So let's look at another example. Great. And we're going to talk about, we're actually going to get more in-depth into edges. Right now, I have 2 points. Right here, and a point over here. And as I take these points, the edge in between these 2 points shifts. It will always be this way, because an edge is created from 2 points. It is not the other way around. Edges do not a point make. Now there's a number that you're looking at down here is a very important number in the description of an edge. In fact, depending on how you look at geometry, you could say that this is in fact the most important number. The number that you're looking at right here is the length of the edge. You'll notice that as I move the points around, the number updates. And of course it does. As the 2 points get closer together, the number gets smaller. As the 2 points get further away, the number gets larger. This is the length between the point on the left and the point on the right. I do not realize, of course, I have said that in reverse order. This would be the one on the right, and this would be the one on the left. That does not change, however, that the distance is updated as these 2 vertices move in space. If I take these 2 vertices and move them together in a simultaneous and similar fashion, the number itself will not update. So it is not enough to say that when points move, the distance between the points changes. While that is often the case, it is not always the case. What is true is that when one point moves in reference to another one, so according to this point, according to the point on the left, that should be this one, the point on the right has just moved up and just moved down. If I move these together, then from the perspective of these 2 points, they're not actually moving. It is only when you place them in space and you can calculate their 3D coordinate positions, as we have right here. So, go back. Lesson number 1. Most important measure of an edge is its length. The length is given by the 3-dimensional positions of the 2 vertices that create this edge. Now the next point to make is that an edge is only and always created by 2 vertices. An edge is not created by 3 vertices. It doesn't happen. Now I'll show you an example of where you might think that an edge is created by 3 vertices. First, let's have a new point. Oh, here we go. Here's a new point. And then let's just drop this point right there. So this point is now halfway between these 2. And you might think, it might be very tempting to think that this is an edge with 3 points, 1 in the middle. But do not be deceived. This is not the case. As soon as we add this point in between the other 2, what we have done is split this single edge. Right? We've taken this single edge, what was once a single edge, and is now 2 edges. To further illustrate the point, we'll change the color of one of them. we have now our two unique edges being defined by three unique vertices. To further prove the point, let's break this edge. And let's move the point down a little bit. There we go. These are now two complete edges. Of course, as soon as we did drop that vertex in, they were always two edges. However, when two edges, let's go back to that, when two edges are in a straight line, it is very tempting to think that what you're looking at is one edge with a vertex in the middle. But again, do not be deceived. This is not the case. This is, in fact, a broken edge, or what is really the case, these are two separate, distinct, unique edges. This is very important to know. Some other properties of edges. 1, an edge is always planar. What does that mean? That's simple. It means that an edge is always on a plane, which, if you think about it, makes pretty good sense to me.